Welcome to the deep dive. Today, we're really digging into something big happening in software development. It's this rise of prompt-driven coding. We've been looking through stuff from coding to prompting, episode 4, and honestly, it looks like a pretty fundamental change.
Oh, absolutely. It's moving beyond just writing code line by line. Now we're seeing more use of natural language prompts to get these sophisticated AI models, the LLMs, to actually generate code for us. It's quite an evolution.
Okay, so let's make that real. What does this actually mean for someone, sitting down to code the old way? The source had a great example. Let's say you need a Python function, maybe to check if an email address is valid. That usually means regular expressions, right?
Yeah.
Which can be tricky.
Tricky is putting it mildly sometimes. You'd normally have to, research the standard RFC 5322, that's the one for email formats, figure out the regex pattern, write it, test it. It takes time. Could easily be a decent chunk of your afternoon, depending on how complex it gets.
But now, the source says you could just, type a prompt. Something like, write a Python function using regex to validate an email based on RFC 5322. And poof, the code just appears.
Well, maybe not poof, but yeah, the LLM can generate that function pretty quickly. And what's striking, initially at least, is just how fast and easy it seems compared to doing it all manually. Tasks that needed specific knowledge, maybe a lot of research, suddenly seem much more accessible, or faster anyway.
Okay, but that sounds almost too good to be true, which leads to a really key point the source hammers home. This AI-generated code. It's not always perfect, is it?
No, definitely not. And that's super important to grasp. The material mentions hallucinations. That's where the AI spits out code that looks totally plausible and syntactically correct even, but it's just wrong. Or it doesn't quite do what you asked, or has subtle bugs.
So you can't just take it on faith.
Absolutely not. You really can't.
Which means our old friend testing, still very much needed. The source mentioned testing frameworks specifically.
Undeniably. Yeah, the source is clear. Don't throw out your testing frameworks. Rigorous testing, validation, code reviews, all that good stuff. Still completely essential. You have to make sure the code actually works correctly and efficiently, regardless of whether you wrote it or an AI generated it.
Makes perfect sense. And that ties into another big idea from the source.
Yeah.
You actually need to understand the code the AI gives you. It's not just about copying and pasting.
Exactly. Blindly using code you don't understand is, it's risky. Think about if you don't get the logic, how can you debug it when something goes wrong? Or maintain it, or even integrate it properly. It becomes this black box.
Yeah, a black box you're suddenly responsible for.
Right. The source had a nice analogy for this, thinking of LLMs as like pair programming with a very advanced, but maybe slightly unpredictable partner.
I like that. It emphasizes collaboration, doesn't it? It's not replacing you. It's working with you.
That's a really healthy way to look at it, I think. These are tools to augment our skills, make us faster, maybe help us learn. But they don't replace the need for fundamental understanding of programming. Not at all.
So what tools are actually enabling this? The source mentioned a few names, GitHub, Copilot, Tabnine.
Yeah, Replit and Mutable AI are in there too. These platforms are essentially the interface. They're embedding these powerful LLMs right into the developer's environment, into the IDE or code editor. So you can just type a comment or a prompt, and it suggests or generates code right there. It's becoming quite integrated.
And it's not just code generation, is it? The source seemed to suggest they do more.
That's right. A lot of them are expanding. They can help with debugging. You might describe the error in plain English. They can assist with refactoring code, cleaning it up or restructuring it, and even generating documentation automatically based on the code, again, often driven by prompts.
Wow, okay. That sounds like it could really shake things up in terms of how development teams work. How does the source see this affecting developers at different stages, like juniors versus seniors?
Well, the thinking is, for junior developers, these tools could be amazing learning aids. Imagine getting stuck on a concept, and you can just ask the AI to explain it or generate an example in a specific language or framework. It's like having a tutor on demand, almost.
That could really speed up the learning curve. What about experienced developers? Are they just automating themselves out of a job?
Probably not. For senior folks, it's more about automation, I think. Automating the repetitive stuff, the boilerplate code, maybe generating unit tests, things that take time but aren't necessarily the most complex problems. This frees them up to focus on the harder stuff, system design, architecture, complex logic. So the potential for a productivity boost across the team seems pretty significant.
But with all this power, there have to be some concerns, right? Some ethical questions, maybe?
Oh, absolutely. The source definitely touched on some important ones. Code ownership is a big one. If an LLM generates code, who owns it? Especially if that model was trained on vast amounts of existing code, some potentially under restrictive licenses, it gets murky.
Yeah, the intellectual property side sounds complicated. What else?
There's the concern about skills. If developers rely too heavily on generated code without understanding why it works, could we see a decline in fundamental programming skills over time?
A sort of de-skilling effect.
Potentially, yeah. And another critical issue is bias. LLMs learn from the data they're trained on. If that data reflects existing societal biases, the generated code could inadvertently perpetuate those biases. Think about applications in finance, hiring, or even law enforcement. That's a serious risk.
That's a really crucial point. So developers and the companies making these tools need to be mindful of that bias.
Extremely mindful. Working towards fairer, more representative training data and building safeguards, it's essential. It has to be part of the conversation.
Okay, so let's shift to practicalities. For someone listening, maybe a developer who's thinking, okay, I want to try this out, what's the advice from the source? How do you get started?
Good question. The source suggests a few things. First, just familiarize yourself with the tools out there. Try out Copilot or maybe one of the others. See how they feel in your workflow.
Just dive in and experiment a bit.
Exactly. And experiment with prompts. Writing good prompts is becoming a skill in itself, prompt engineering. See what kind of instructions work best. How specific do you need to be? How do you refine a prompt? If the first result isn't quite right, it's iterative.
So it's like learning to communicate effectively with your new AI partner.
Precisely. And the second key piece of advice, which we keep coming back to, is understand the output. Really analyze the code it gives you. Does it make sense? Does it have edge cases? Is it efficient? Don't just trust it blindly. Make sure it actually meets your requirements.
Test, verify, understand.
Always. And finally, the source encourages staying informed. This field is moving incredibly fast. Keep up with best practices, read discussions, maybe share your own experiences. Be part of the ongoing conversation about the tech and its implications, including the ethical ones.
Right. Continuous learning is key here.
Definitely.
Okay, so wrapping this up, this deep dive, drawing from coding to prompting, episode 4, shows that prompt-driven development is, well, it's powerful. It's here. It offers huge potential for speed and efficiency, but it's not magic. There are real considerations around accuracy, understanding, and ethics.
Absolutely. And that skill, prompt engineering, knowing how to talk to these models effectively, it's becoming genuinely important for developers. It's a new layer on top of existing skills.
So here's something to maybe leave you thinking about. As AI gets woven deeper and deeper into how we actually create software, how might that change the very definition of what a developer is in the coming years? What will that role look like? Something to ponder.